let us introduce you to the hypothesis test. So as green belts, we have seen that in the analyze phase, we were interested in establishing the relationships between the y and the x factors. So we had the x factors and the y, and there were different possibilities. The possibilities were the y was continuous or attribute, and x was either continuous or attribute. So in this case, let's say, if I'm looking at the y and the x factors, let's assume in one case y is continuous, and in that case the possibilities for x factors would be either it is attribute or it is continuous. And in the second case, the possibility can be the y is attribute and the x factor is again either attribute or continuous. Now, once I've got these four possibilities, there is no fifth possibility. So how to deal with them? We had seen in the green belt that when I deal with attribute data, usually I can identify it. It is generally categorical data. It's always categorical data, in fact. So we started identifying the categories. Say, for example, if I want to look at the procurement time, I take the time, procurement time. It could be the reason of one of the X factors could be specifications, clarity. Clarity of specifications. And one of the other X factor could be, let's say, delivery time. The delivery time. Now, if I'm looking at continuous y and attribute x, usually what I do, I find the 2 or 3 categories. And here specifications were clear and they were not clear. And then we were looking at, is clarity impacting? So obviously we collected some data. That's what we did. And when the specifications are clear, the time was, let us say, 90, 90, 91, and 92. And when they were not clear, the time was 120, 121, 122. So specifications are clear, specifications are not clear. Looking at this data, it appears that specifications clarity is affecting the procurement time. Okay. Looking at the data, it appears that specifications clarity is affecting the procurement time. And what I would do is I would make a box plot. That's what I did. Here there's a time, and then so clear, not clear. And there were 2 possibilities, in fact. Clear and not clear. When it is clear, we look at, let's say, time taken is less, the time taken is high. Here, time taken is almost same. So in this first situation A, I will say clarity is impacting, clarity is affecting. And in the second case B, I would say the clarity is not impacting. That's what I concluded in the green belt. Similarly, for delivery time as well, I collected the time. Of course, here both X and Y are continuous data. So I collected the data where procurement time and the delivery time were plotted on a graph that is known as scatter plot. And then once we plotted the graph with the delivery time, and this is the procurement time. If this was the case, we would say that, well, it appears that procurement time is impacted by the delivery time. And in the other situation, we said that it is not. For attribute and attribute, let us convert the procurement time problem into whether the procurement is delayed or not delayed. Or I can even think, if I'm investigating the procurement time, I can even investigate whether the procurement is having defect or not. Let's say I'm talking about the errors. So if I'm talking about the errors, see, the as a black belt, what you need to remember that as a black belt, you can always work on both continuous and attribute data with confidence. And also you can work on 2 CTQs. So someone gives you a process, a procurement to be improved, and you are told that, well, this is a procurement process and please improve. Earlier we selected only 1 CTQ, that was procurement cycle time. As a black belt, you can select 2 CTQs. I would like to reduce the cycle time, as well as I would like to reduce the errors also in the procurement. So let us say that we are working on 2 CTQs. Because I really want to have a Y, which is attribute right now. So procurement, mistakes in procurement, let us say. Now mistakes in procurement, it is continuous or attribute? Obviously, it is attribute. Mistakes is attribute. Mistakes or no mistakes. So now I want to reduce the mistakes in my procurement time, mistakes in procurement process. And now mistakes depend on, let us say, again, let me take specification clarity as one of the X factors. Specification clarity as one of the X factors. Specifications are clear or not clear. Now here I can create a table. If you remember, we created in Pareto analysis, we created a table. So here I can create a table. Now here we will create a frequency table, and this frequency table will be a little different, and this will help us to do other tests like chi-square test. So when I'm dealing with attribute and attribute data, I'm dealing with right now attribute and attribute data, I will create a table, and this table would look something like this. Let us say I want to create this table which has specification is clear or not clear, and output. So specification clear, let me write it. Specification is clear and not clear. Now if I give you this data saying that when the specifications are clear, I commit 10 mistakes. When the specifications are not clear, I commit 20 mistakes. And if someone asks you, is clarity impacting? You might say, yes, clarity is impacting. When the specifications are not clear, we commit more mistakes. But because we are a black belt, you have to always remember that when you deal with attribute data, you have to look for categories, the two categories. So when someone talks about mistakes or errors, you have to also look for the other category. You have to ask, tell me about the other category as well. Tell me about the next category. What is the other category? Mistakes, no mistakes. So now, right now, if I'm asking clear, not clear, but out of how many, which is what is the other category? I want to know the proportion. And someone tells you that, this is of course number of mistakes. So if I just write it down here, mistakes, and let's say no mistakes, or let's say total, out of total procurements. And I create a table. Out of 100 procurements, when the specifications were clear, we committed 10 mistakes. And out of 200 procurements, when the specifications were not clear, we committed 20 mistakes. Now, based on this, what do you feel? Is specification clarity impacting my number of mistakes or errors in my procurement? If you see carefully, 10 divided by 100 is 10%. 20 divided by 200 is also 10%. So you can say that specification clarity does not matter. It is not the root cause. We are not saying it doesn't matter at all, but it is not the root cause. Look for some other root cause. When specifications are clear or not clear, still people are committing the mistakes. So if you think that if I make the specifications very, very clear and your mistakes will reduce, definitely not. Because when the specifications are very clear, still people are committing the mistakes. So sorry, specification clarity is not the root cause. That's what you will see. Okay, I hope you understood this. And obviously, suppose if I just want to change it, I would just like to change this to when the specifications are not clear, I'm committing, let us say, 100 out of 200. Then yes, with confidence, I can say that yes, clarity matters. If our specifications are clear, I commit less mistakes and I should work on reducing the non-clarity or increase the clarity of the specifications. So this becomes my root cause in this case, or another case, it is not the root cause. Now let us look at the other one. Mistakes. Is it dependent on, let us say, time taken to checking time to check the let's say request, time spent on checking or studying the purchase request? Is it dependent on that? No. Let's say, so I would say mistakes committed on mistakes are dependent on time taken, study time. So I'm studying, I'm studying the documents, how much time I spend on the documents, studying the documents. If I spend more time, does it reduce my mistake, or if I spend less time, does it increase my mistakes? I want to know that. Now here I will just write it, study time, document study time, document study time. The documentation study time is the X factor, and the Y is the mistakes. Now, if I look at the data, documentation study time. And let us say the attribute data is mistakes or no mistakes. Now the Y here is attribute. So I will put mistakes or no mistake. Suppose here I can represent as 0 and 1. So 0 means no mistakes. I have two categories, so I'm just representing it as 2, 0, and here I am putting as mistakes. Mistakes as I'm putting as 1. If I just spend 0 time the study of the document, 0 minutes. Probability, this is the mistake probability, right? Probability of committing a mistake is 100% I'll commit. If I spend 10 minutes, it is definitely still the probability I commit a mistake. If I spend 20 minutes, spend more time. So it goes on and on. This I can represent as probability. Now, if I go on and say, if I put, let's say, let us make this x as hours. So 0 hours, probability of mistake is 1. 2 hours, 1 hour, 2 hours, probability of mistake is still 1. At around, let us say, 1, 2, 3, 4. At 4 hours, there was no mistake. So I have got both the data. At 4 hours, I had mistakes, and at 4 hours, I did not have mistakes. At 5 hours, I've got both the data. Sometimes I commit mistake, and sometimes I don't commit mistake. And after 5 or 6 hours, the probability of getting the mistake is 0. Means basically I did not commit the mistake. How are we collecting such data? I have got the y and I have got the x. X means 0 time mistake is yes. 1 hour mistake is yes. 2 hour mistake is yes. 3 hour mistake is yes. 4 hours mistake is yes. And 4 hours mistake is no also. At another 5 hours mistake is yes. Another 5 hours mistake is no. So there is an overlap here, right? Now, if I ask you, if I study the document for 5 hours, if I study the document for 5 hours, what is the probability? What is the probability? If I study documents for only 1 hour, the probability of committing a mistake is 1. If I study the documentation for 20 hours, the probability of committing the mistake is 0. But if I study the document for 5 hours, you would say that probability of committing the mistake is around 50%. So this S curve will be obtained, which will be my probability curve, probability of committing a mistake. And this is known as a binary logistic curve, which we'll be studying in the binary logistic regression. So as a black belt, you won't do the box plot. Of course, you'll do the box plot just to get an idea whether clarity is impacting or not. But instead of box plot, you will rely on ANOVA. As a black belt, you will not draw a scatter plot only. You will not stop there. You will be doing regression. As a black belt, you won't be stopping with a Pareto chart. You will be doing chi-square tests. Whenever you get a table with an attribute, you will be doing chi-square tests. And when, as a black belt, you are dealing with the data where y is continuous and x is attribute, then you will be doing binary logistic regression. Binary means I'm just putting 0 and 1. I'm just interested in 2 categories. So that is why it is binary logistic regression. Okay. So now, if we are looking at binary logistic regression, I'll just start mistake. Okay. So these are the 4 tests which we'll be studying. Now, if I have got only 2 categories, suppose I have got only 2 categories, clear and not clear. Instead of ANOVA, I can also use 2 t-tests. If I have got only one X factor versus Y, I use a simple linear regression. But if I have got multiple X's, I can use multiple regression. If I've got only two proportions, two categories, and here also mistakes or no mistakes, here also two categories, I can also do two proportion tests, but I can even do chi-square as well. So even if you just learn chi-square, that's enough. But usually two proportion is also sometimes helpful when you're comparing before and after, whether the defects have reduced or not. So sometimes it gives you a good result if you take those before and after results. And later on, we'll also see that a 2T test, it has got some more variants like paired T-tests. So we'll study that as well. So these are the different tests which we'll be studying in the hypothesis test. Also, one more thing, if you are just interested in, suppose I'm not interested in the relationships between X and Y, I'm just interested in just making a statement about the Y. I'm just making a statement about the Y. Procurement time in our company is equal to 122 or more than 122. I'm just want to make a statement. Is it equal to 122 or is it more than 122? Yes or no? If I am making a statement only about one factor, I can also do one t-test. Or if I want to make a statement about just proportion of mistakes, we commit 7% of mistakes in our process. Is it more than 7 or less than 7 or equal to 7? If I want to make a statement about just the proportion of mistakes, I can do a 1p test. So 1p test for only one proportion, 1p test for only one proportion, and 1t test for only one continuous data against the number. So procurement time is equal to 122. 122 is number. Proportion of mistakes is 7%. 7% is a proportion. 0.07 is a proportion. So when I'm looking at the data, continuous or attribute, and measuring it against a number, I'm interested in establishing a claim. I claim my procurement time are taking less than 120 days. Then in that case, I will use 1t test or 1t test. Now, having understood the tests, let us also understand that as a black belt, you are a scientist. You give equal chance to all the possibilities. So I have got a Y, I have got an X. I will create two hypotheses. The two hypotheses which I'll be creating is or are the two hypotheses. First hypothesis is null hypothesis. Null is X does not impact Y. X does not impact Y. And what is alternative? X impacts Y. It also means that the first null hypothesis is X is not the root cause. X is not significant. I can also write it as X is not significant. It is not the root cause. And here it is X is significant. It is the root cause. Let us say one more way of expressing it would be null is X is not root cause. And here it is X is the root cause. So null and alternative you'll be writing means as a black belt you're giving equal chance to both the possibilities. So when someone says Can you tell me procurement time, is it impacted by the specification clarity? Well, you say maybe or maybe not. You're a black belt, isn't it? You say, let the data prove it. You can't rely on your logic, intuition, experience. Remember what Deming said, in God we trust, rest others bring data. So I'm not going to trust you unless you give me the data. Let the data prove whether clarity is impacting the procurement time, whether the specification clarity is impacting the mistakes, whether the delivery time is impacting the procurement time, etc., etc., etc. So null and alternative, I'll create those null and alternative. Okay. Once I create this null and alternative, then I will collect the data. So first thing what I did was I created a null and alternative. I created a null and alternative hypothesis. And well, also I can also establish one more thing. So this is the first step. When I'm doing a hypothesis test, this is the first step. The second step could be I also decide my confidence level. Means what is the risk of me going wrong? How much I can tolerate the risk of going wrong? We call it as alpha error. Usually, this is also known as type 1 error. Usually, we take alpha equal to 0.05, that is 5%. So the confidence level becomes 95%. So we choose an alpha level of generally 5%. So the confidence level becomes 95%. Now you can choose a 1% also, then your confidence level becomes 99%. But careful, be careful. If you choose too much of confidence, you won't be making any decision, any real decision in life. Suppose you don't want to take any risk, then don't do anything. Then so as a scientist, as a black belt, you accept some chance of going wrong because based on some samples. Say for example, here I collected the data. Here I collected the data. Clarity is impacting the procurement time or not. Now, based on this data, with this data, based on this data, I can say with the 95% confidence, in fact, not even 95, I would say with 99% confidence, I can say that clarity is impacting with this kind of data, isn't it? But generally the confidence level chosen is 95%. Let's stick to it. That's like a thumb rule, and that's what we will follow. But having said that, just remember confidence level can be 99 also, can be 90% also. Okay, so we'll talk about, see, depending on your alpha, there are different adjustments we do. There are two types of error, alpha error and beta error. We'll talk about that a little later. But right now, just focus on the alpha error because we are more interested in not making a wrong statement. Means when the specification clarity is not impacting, I'm interested in not making a change. That's what I'm interested in. So I'm more focused on alpha. So right now, I want to protect myself from making a wrong judgment and making the company change its policies based on, see, you are a black belt. Company listens to you. When you say clarity is the important thing affecting the procurement time, company will start changing its processes, changing the templates, buy some software based on your recommendation because you're pointing a finger toward one X factor. You've told that this is an X factor which is responsible. Now, better be confident, better be 95% confidence when you are proposing a change in the process of the company. Please be 95% confident. That's what the company is requesting you. That is why we are saying 95% you should be confident. At 5%, well, you can't be 100. If you want to be 100% confident, then you say do nothing. Just sit quietly, do nothing. You are not at risk. But now, with a small risk of 5%, you are recommending our templates should change. The specification clarity is really impacting our procurement time, and we need to make some changes. So that is what you are expected to do. So that is why we are choosing the alpha error as 5%. Then comes our next step. Then we collect the data. We collect the data. And we collect the data on the X and Y. And then after that, we apply the appropriate test. Whatever is the appropriate test, we will apply whatever is the appropriate test. So, or conduct appropriate tests. Conduct the appropriate tests. Whatever is appropriate, depending on X and Y. Conduct appropriate tests. And then after that, what you will do? Get the p-value. You'll obtain a p-value. All tests will give you some p-value, which is probability of you going wrong if you reject null. Probability of making a mistake. Or I'll just write probability of you going wrong if you say that X is the root cause, or if you reject null. Okay, I'll just toggle. Rejecting null means you're telling X is the root cause. See, rejecting null means accepting HA, alternative hypothesis. That means you're saying that X is the root cause. And if your p-value, if p-value is less than 0.05, if p-value is less than 0.05, you will reject null. And if your p-value is more than 0.05, if your p-value is more than 0.05, then accept null. So that means if your p-value is less than 0.05, you will say X is significant, X is the root cause. And if p-value is more than 0.05, X is not the root cause. That is your conclusion. Just remember, if I want to remember this p is less than 0.05, reject null, p is greater than 0.05, accept null. I can also remember by using this this two-liner, a poetry. This poetry is something like if p is low, null must go, and if p is high, null must fly. So null must go, null must go. P is low, null must go. P is high, null must fly. Okay, so P is low, null must go. P is high, null must fly. You can just remember that. And so this becomes our route map to hypothesis tests. So null is always X is not affecting. Null is always. It has to be chosen. Always X is not affecting the Y. Okay, that is the norm. Okay, you can't choose null is affecting the Y alternative. You can't choose like the way you go to England, they will say you have to drive on the left side. So you may ask why. I'm from US, so Englishmen will say, well, this is UK, this is England. You have to drive on the left side. That is how we have decided. So that is what has been decided. You can just treat it like that. Because just choose always null as X is not affecting the Y, and the alternative is X is affecting the Y. In only one case, in only one situation, in only one situation, nowhere else, in this case, of specification clarity, like here, this case and this case. Null, I can change it a little bit. I can change, like it is one and the same thing. What I can state is null is, instead of saying specification clarity is not impacting Y, I can say the mean time, mean procurement time when the specifications are clear is equal to, like these two are equal. I I can just say these two are equal. Two are equal. 2 when it is not clear. When it is not clear. Okay. And alternative is mu clear when the mean procurement time, when the requirements are clear, are less than mean procurement time when the requirement is not clear. That is what I suspect. So in this case, I can change the hypothesis, null hypothesis, alternative hypothesis, so that it becomes easier for me to make a conclusion. But actually, when I say clear is not equal to not clear, it is one and the same thing. It's just telling you the clarity is not impacting. It doesn't impact. It doesn't mean, it doesn't affect, it doesn't influence. The clarity doesn't influence. You are clear or not clear, still the procurement time remains the same. That's what you are saying here. So in this case of ANOVA or 2 t-tests, we'll remember. So what we will do, we will just do a quick demonstration on Minitab on procurement cycle time, and just so you have to just watch, you have to just see. You don't have to really do it with me. We will see that later. We'll all do a little later, and
this conference will now be recorded.
Now let us apply the same steps of hypothesis testing to our procurement time example. Is procurement time getting affected by the clarity of our requirements? So clarity is attribute data and procurement time is continuous data. I had used a box plot earlier. Now I can use a ANOVA, analysis of variance. So what is the null hypothesis? The null hypothesis is that I can write it down. Null hypothesis is X does not impact the Y. That means clarity does not affect procurement time. That is my null. An alternative is clarity affects the time. That is our alternative hypothesis. I can also write it, because it's an attribute and continuous combination, I can also write the null and alternative like mean time taken, procurement time, when the requirements are clear is equal to when the requirements are unclear, and when the requirements are clear, the time taken is less as compared to when it is unclear. Okay. So whichever way, it's one and the same thing. Now looking at this, so null is procurement time is not affected by clarity. That is my null. Now I'll do an ANOVA. Procurement time is procurement time, and the factor which I'm studying is clarity of requirements. Okay. See the 95% band also, I'll talk about it a little later. Okay, let me talk about right away. So look at the clarity when it is high. The average procurement time is how much? 122. But that is for the sample. That's for the sample which we have collected. But for the whole population, the 95% band of my mean procurement time using the central limit theorem is 120 to 124. So there's a likelihood of mean of the population when the clarity is high will be between 120 to 124. And when it is low, it will be between, of course, right now it is somewhere around 127, but population is likely to lie between these two values. But there is no overlap between the two. You can see there's no overlap. So very less probability that high is equal to low. It appears that they are different. But I will not look at the graph always. I'll look at the p-value, and the p-value is how much? Let us see the p-value. 0.006. P is lower than 0.05. I'll reject null. I'll say yes, clarity is the root cause. Clarity affects. Clarity is the root cause. So P is low. P is low here. P is lower than 0.05. It is 0.006. So I'll say I'll reject null. I'll say yes. Reject null. When the requirements are clear, it takes less time. That means clarity impacts the time. That's what I'm going to make a conclusion. Similarly, let us look at the other parts. Let us look at the procurement time. Is it affected by the approval delay? Approval delay is yes or no. Here it is attribute data. So I'll just look. I'll look for ANOVA again. ANOVA. So I'll just do ANOVA here. Stat ANOVA on again procurement time, and this time I want to study the approval delay. Yes or no? Approval delay. Where is it? Approval delay. Yeah, it's here. Approval delay. Okay. Well, approval delay, when it is not there, it is less, little bit less, a little bit high, but that little bit is meaningless. Look at the population, the uncertainty. They are matching. I can't say for sure, but well, we won't look at the graph. We just look at the p-value. Let us look at the p-value. P-value is high. 0.59. P-value is high. 0.59. P is high. Null must fly. P is high. Null must fly. That is, X is not impacting. That means what? Approval delay is not impacting. Approval is delayed or not delayed. Doesn't matter. Approval delay, the procurement time is equal to when the approval is not delayed. Doesn't matter. Not the root cause. Why? Because the p-value is high. How much is it? P-value is 0.59. 59%. You will be 59% wrong if you say that approval delay is the culprit. You will be 59% wrong if you say that approval delay is the culprit. So better. Do you want to be 59% wrong? No, I want to be only up to 5% wrong. So because 59% or 0.59 is greater than 5%, 0.05, well, I'll say, well, don't worry. I don't think the approval delay is really the root cause. Root cause is something else. Look for some other X factor. So here I would not suggest the organization to make any changes related to approvals. Continue with the same approval system, doesn't matter. It is not going to have any impact on your procurement. But if the other way around you have found, let's say, if you had found that yes, approval delay delays your procurement, then you would have told, change the approval process, reduce the approval steps, whatever you would have told, depending on that particular process. But right now, we are focusing on just finding the root cause. So here I would say approval delay is not responsible because p-value is high. Clarity, it is responsible because p-value is low. Using some hypothesis test, I found out. If you see carefully, approval delay, no and yes, there are only two categories. So I can even, when the approval, I can unstack the data. When the approval delay, there is no approval delay, I can put the data here. And when the approval is delayed, I can put the data here. So I have now two categories. So I can even do a 2T test. I did an ANOVA, which was also correct, but I can also do 2T test. Why? I have two samples. One is continuous, one is attribute. By the way, these are categories. Don't think Both are continuous. Yeah, remember, please remember this. This is continuous data. This is attribute data. I've just unstacked and created the separate columns for the two categories right now. So now I've got two samples in two different columns for the two different categories. So I can also use two t-tests. It will also give me the same result. In approval delay, we found in ANOVA, they are not impacting. If I use two t-tests, still I'll still find that they are not impacting. Let's do that. Two t-tests. Two t-tests. So we will all do this test together. We'll try to solve some example. Right now, I'm just showing you some to show you the flow of the hypothesis test. I'm just taking this example. So I've got approval delay, no, and approval delay, yes. There are two categories. And what do you think? What is the null hypothesis? Null is approval delay is equal to approval no delay. And what is the alternative? I feel that when there is no delay, the time is less. That's what I feel. So I'll just say less than. I'll just say the alternative hypothesis is less than. I'll just put it that. And p-value is 0.29. It is high. You'll be 29% wrong if you say that approval delay no is less than approval delay yes. So there is no difference between the procurement time, whether the approval is delayed or not. That approval delay is not the root cause. Okay. So this is how we make our conclusions.